In this video, I am going to talk about few details about software requirement specification. Actually, in short term, we call it as SRS document. Okay, so we need to understand and we need to specify the requirements that is going to be needed in our project. Suppose if you are going to develop some project and so that you can try to solve a problem. That problem might be small also, that problem might be large also. So for small problems, it is easy to determine what are the things you will need, what are the specifications you will need, and it is easy to document that thing. But if it is a large scale project, if it is a large scale problem, and that you are going to complete or develop through a information system development or system analysis and design, then to document all the things might be very hard and probably the hardest, most problematic and error prone. That is why it is very important to maintain the things from the earliest. So in the requirement, actually we follow 2 points, that is input and output. Input means what user needs in minds of people, hopefully means what people will require, what user will need in the through the software, through the project, through the system we are going to develop. Output, precise statement of what the future system will do. So output, so in the requirement task, output also will be there, like what will be future system will provide, the system you are going to develop, that what that system will provide, that precise statement should be there. So 2 parts, that is requirements, it can be divided in 2 parts, input and output, that requirements associated with these 2 terms. So basically there are challenges like identifying and specifying the requirements. That is the main challenge. Necessarily involves people interaction. So to identify and specifying the requirements, we need involvement of lots of people, and we need to interact with them, and it cannot be automated. We cannot automatically decide what thing will be required. It will be only solely based upon the need of the output or need of the input. So what is the requirement? A condition or capability that must be possessed by a system. It means like that the system's conditions that we need to meet, or system's capability that we need to meet, or systems desired input or output that we have to provide. What is the work product of the requirement phase? Work, but it is the main part. The product of this requirement analysis phase is that software requirement specification, SRS document. So what is an SRS? SRS is a complete specification of what the proposed system would do. So SRS is a complete specification of what the proposed system should do, how it will provide or how it will use. So in the background, actually requirements understanding is hard for large system, but for smaller system it might be easy. So visualizing a future system is difficult sometimes, but you have to go through it one by one step at a time. Then only you can understand the requirements, and you have to analyze parts by part, step by step, section by section of the project. Capability of the future system not clear. Obviously, when you are visualizing the problem, or while you are visualizing the future system, initially it might not be clear about what is the capability of the future system. Hence, it needs to be more clear. Requirements changes with time. Obviously, so the requirement might change with time. Essential to do proper analysis and specification of requirements. That is why it is very important how you analyze and how things can be done. That is why proper analysis and specification of the requirements need to be put in the SRS document. So what is the purpose of the SRS document? SRS establishes basis of agreement between user and supplier. So here very important two point or two stakeholders, that is user and supplier. So it establishes the agreement between the user and supplier. So user needs have to be satisfied obviously, but user may not understand the software, so that is a challenge. Point is that initially user might not know what system will provide or know how system will work, but we need to, or the system developer need to satisfy the user needs, and developers will develop the system but may not know about the problem domain. Developer like coder or tester will develop or test the system but may not know the main problem domain. That is why as an analyst, software analyst or system analyst or designer, you need to provide all these things. So SRS is the medium to bridge the communication gap and specify user needs in a manner both can understand. So that is what it is about SRS. So what is the need? Helps user understand his needs, his or her needs. User do not always know their needs. That is why we have to understand, must analyze and understand the potential, and the requirement process helps clarify the needs. That is why this requirement analysis process helps us or helps the analyst to clarify the needs that will be required throughout the system development. SRS provides a reference for validation of the final product. So SRS also provide a validation or verification, you can say, means complete proper validation can be given through SRS because it provides a clear understanding about what is expected from the system. So validation is software satisfies the ARS. So high quality SRS is essential for high quality software, and requirement errors get manifested in final software. So to satisfy this quality objective must begin with high quality SRS. So before you develop a high quality software, you need to go or you need to start with high quality SRS. So requirements defects cause later problems. Obviously, if you faultily input the requirement specifications, then in the end of the software or in the final product, it will create some error. It will obviously lead some error. 25% of all defects in one study and 55% of all defects and after using user testing. So it can occur. That type of defects can occur. So defects often found in previously approved SRS. So obviously, so here you can see if 25% of all defects in one study and 55% of all defects found after user testing. So it says that the approved SRS contains the defects. If the approved SRS does not contain any defects, then after testings or during the study, that error or that defects might not be there. So that approved SRS need to be more clearer and error free. So good SRS reduces the development cost. Obviously, it will give you a clear path. You will not go here and there while developing the things. You will go in a clear path. In that way, your cost will be in a track line, base track line, and you will not incur any other losses. So in that way, it will help you and it will reduce you during the development, reduce the development costs. Okay. So SRS errors are expensive to fix it later. Obviously, if you create the final product and you cannot alter the errors, then it will create a heavy loss for the software also. And if you want to minimize the error also, then also you have to alter all those things that the error caused. So in that way also you will lose many things. That cost will be huge, and requirement changes can cost a lot. That is why requirement changes, if you change the requirement after the final product, then you have to make it again, then it will may cost lot. Good SRS can minimize changes and errors. Obviously, good SRS will provide you a clear path, and in that way it will minimize the changes and the errors. Substantial savings, extra effort spent during requirement saves multiple times that effort. Obviously, that is the point, the need of SRS. An example, cost of fixing error in requirement analysis, designing, coding, acceptance testings, operations are 2, 5, 15, 50, 150% per month. So you can see for every stages it increases the efforts in terms of person per month. If you do not provide a good SRS, high quality SRS, then fixing the errors, during the fixing the errors, the cost will increase in that way for every step of the development process of that product. So requirement process, actually basic activities are like, we need to first understand the problem and analyze the requirement, then we go for requirement specification, then we go for validation. So analysis involves elicitation and is the hardest. So that is why in this first stage itself, analysis involves elicitation and it is the hardest. So you can see here, initially you try to find the needs of the user, you try to analyze need of the user also, need of the software also, and you try to build the analysis phase. During the analysis phase, you might use lots of other tools, lots of other systems, lots of other designing methods or analysis methods. Then you will try to specify the things, specify the system requirements, and again you try to feedback the analysis stage, and again it will feedback the specification stage. After specification is done, then you will go for validation. So process is not linear, it is iterative and parallel. Overlap between phases may occur. Some parts may be analyzed and specified, and specification itself may help analysis because it might give good feedback, and you can again analyze the things, and again you can give the specification requirements in the document, and after document is done, you can validate the things. Validation can show gaps that can lead to further analysis and specification, and it again give feedback to this analysis and specification part. So in that way you can create a SRS document. So in the requirement process, divide and conquer is the base strategy or basic strategy, because there might be lots of components in a software or in a product information system. So we need to divide it in small parts. You need to understand what are the needs, what are the requirements for each part, understand each part and relation between the parts. Obviously we need to understand the relation also in between the parts, and then we have to merge all these things to know the whole requirement of the system. And large volume of information is generated during this requirement analysis process, and organizing them is a key. That is very important part. We need to organize the information that we have gathered by decomposing it into small parts, by understanding the relations, by understanding each part. Then we try to understand requirements for each part, then we merge them, and then we need to organize them. Techniques like data flow diagrams, object diagram, etc. used in this analysis. So we will not discuss this part because we have already discussed about what is DFD, and if you require some more about these things or these object diagrams, obviously in later part of this course we'll try to discuss in thoroughly, because in previous videos I have given some hints and brief concepts about DFD and diagrams and all, and also we'll try to understand more about DFD and other diagrams in later part of the course if it requires, if it is desired to know from you. So we'll go to directly what other things we need to know about SRS document. So actually in the analysis phase you try to use DFDs, any other diagrams and all to analyze the task, analyze the parts of the main project. You try to analyze all those things, and those analysis information, those analysis will give specification, and we will go in that specification part. So final output from the DFD or any other diagrammatic tools to analyze the software or the system, it will give or it will lead to requirement specification. So final output requirement task is the SRS. So that is the specification part. So why are DFDs and OO models etc. not SRS? SRS focuses on external behavior while modeling focuses on problem structures. So in the specification part, actually SRS, what it tries to do, SRS tries to focus the external behavior of your system, not the internal behavior of your system. So UI, GUI or etc. not model but have to be in SRS. So error handling, constraint etc. also needed in SRS. So transition from analysis to specification is not straightforward. So after getting the analysis done, after knowing what needs to be done, so after that you need to go for specification. So that transition phase is not so straightforward. So knowledge about the system acquired in the analysis used in the specification. So whatever knowledge you gathered in this analysis phase, you need to use that during the specification process. Suppose you have drawn some DFD like this. After analysis of this, you understand what needs to be done, and then that information, that analysis needs to be inputted in the specification process. So characteristics of an SRS is correct, complete, unambiguous, consistent, verifiable, traceable, modifiable, and ranked for importance and stability. These are the very important characteristics of SRS. It has to be correct, it has to be complete, it has to be unambiguous, no double meaning about any specifications. It should be consistent throughout the document. It should be verifiable. Obviously validation should be there, otherwise it will lead to error. Traceable, it need to be traceable. Modifiable, and there is a scope to modify the documents. There should be some scope to modify documents. And ranked for importance and stability, there should be ranked of the documents or the specification as per the importance or as per the stability. So you can see here the characteristics in briefly in broad way. Okay, you can go through this. So components of an SRS, like what should an SRS contains, clarifying this will help ensure completeness. An SRS must specify requirements on functionality, performance, design constraint, external interfaces. Like what are the functionality of your project, what are the performance of your project, what are the design constraint, what are the constraints you are facing, what are the issues and challenges you are facing during the design process of the software or the system, or what are the external interfaces, like what are the through which the user will interact. It might be input or it might be output. So like in the functional requirements, we will go through heart. This is the heart of the SRS document. This forms the bulk of the space. Specifies all the functionality that system should support. What are the functionality the system will support? What are the features you will provide to the user? So all things, all the features need to be included in the document. Outputs for the given inputs and relationship between them. So outputs for the given inputs and the relationship between them need to be included in the software requirement specification document. And all operations the system is to do, what are the operations the system will do, need to be included in the SRS document. So in the SRS document, whatever analysis you have done, like DFD, like any other use case diagram or any other diagram or ER diagram, all those things, all those information need to be included, because that way you can only understand how the system will work, how it will operate. So must specify the behavior for invalid inputs also. Obviously for invalid input also you need to specify everything. So it is like SRS document is like main manual of your system. Okay, main manual of your system. So performance requirements, obviously all the performance constraints on the software system need to be included. Generally on response time, what will be response time, what will be throughput, will it be dynamic, will it be static, like that. So like here capacity requirements, static or not, must be in measurable terms, should be verifiable, like in units of some times, or like under any other units that need to be included in the SRS document. And design constraints like factors in client environment that restricts the choices. Obviously in some systems, some information systems, some inputs or some environments will restrict the users to or confine the users to only some specific inputs only, or choices might be confined one. So those things need to be included in the SRS document. Some such restrictions are like standard compliance is compatibility with other system. Obviously whenever you develop a system, you always mention that this software or this system will work on this environment only. Those specifications need to be included in the software SRS document. And hardware limitations also, and whatever reliability options, fault tolerance option, backup requirements, security, those things need to be also included in the SRS document. Those are actually constraints, and there might be other constraints also as per your software design process, as per your software development process. And there should be external interfaces like all interactions of software with the people, hardware, software. So here this is not only with the people, this is also with the hardware and software. And user interface most important, that is the GUI part. General requirements of friendliness should be avoided. Like here you can see general requirements of friendliness should be avoided. This should also be verifiable. This external interfaces should be also verifiable. So, and the languages should support desired characteristics of the SRS. Formal languages are precise and unambiguous but hard, and natural languages are mostly used. In general cases, natural languages are used with some structures from the document, and formal languages are used for special features or in highly critical systems. So formal language can be used, like formal language like computer language can be used for special features or in highly critical systems, and but natural language like English or any other language can be used with some structure of the document. So that choosing of the language is also important. And structure of an SRS looks like this. Initially, introduction, it will introduce like what is the purpose, what is the basic objective of the system, scope of the system, what it will do, what not do, an overview of the system, or you can provide some diagram also, overview of the system. Overall description, it will describe the overall description, product perspective, product functions, user characteristics, assumptions, constraints, all those things. Those we have discussed in the previous slides. And also after that, specific requirements, what are the external interfaces, what are functional requirements, what are performance requirements, what are the design constraints. So acceptable criteria, what are the criteria that is acceptable, desirable to specify this upfront. So this standardized on SRS was done by IEEE. IEEE is an organization, worldwide organization, and this structure is done, developed or standardized by this organization. So to develop a project, to build a system, you need to follow while you creating a SRS document. So after that, you need to validate the SRS document. So lot of room for misunderstanding. So there might be lot of room for misunderstanding about the specification you have mentioned in the SRS document. So you need to validate those things. So error might be possible, obviously, but it is very advisable that error should be minimum. Otherwise, it will lead to more cost. Expensive to fix required defects later. So that is why after completion of this validation phase, it will be very difficult to fix the error or fix the defects. So must try to remove the most errors in the SRS. So most common error are like omission. You might delete something, you might remove something, or sometimes you mistakenly not put some information. In that way, it might lead to like errors. So most common errors are like 30% of omission, or inconsistencies like 10 to 30%. Incorrect fact, that might be also 10 to 30%, and ambiguity also 5 to 20%. This type of error actually most common errors, but there might be other errors also. So requirements review, we need to review the requirements. SRS reviewed by a group of people. So SRS documents need to be reviewed by a group of people. That group should contain like author, client, user, developing team, etc. So must include client and user. Obviously you have to include the client and user. Process, standard inspection process. You need to follow a standard inspection process to validate the SRS document, and in this way effectiveness can catch 40 to 80% of requirement errors. So through that way you can catch some errors. 80% of error, 40 to 80% of error can be minimized. So before the final SRS, you can minimize this much of errors through this process, through this review. So at the end, the summary is that having a good quality SRS is essential for UNP. The question and what? It is your homework. The requirement phase has three major sub-phases: analysis, specification, validation. Analysis for problem understanding and modeling, method use, systems analysis and design, object-oriented method, prototyping. Those things need to be included. Key properties of an SRS: correctness, completeness, consistency, traceability, unambiguous. So these are the things important. Specification must contain functionality, performance, interfaces, design constraint, most necessary languages used, validation through reviews. So that's it. That's it all about SRS document. So try to go through it, and some slides I have not included already in the documents, like here you can see some topics about DFD. How can this part actually contains in the analysis phase, so I have not going through that phase. You can go through it through the slide that will I provide through Google Classroom, and because we have already gone through DFD, but also you can go through it along with this SRS document, which is very important phase also, that is done during the analysis phase. So that analysis phase actually includes those DFDs and other prototyping things. Any other models you are going to use, or any other diagrams or any other analysis techniques you are going to use, that will be used in this analysis phase. So if you have any problem, please let me know. So thank you.